I feel like the most common practice for a beginner FTC team is to write the entire OP mode into one single file. I'll be honest, I did it, and so did everyone at some point in their life. The problem is, while it might sound easier, it will be more time consuming in the end. Not only your code will become much more cluttered, but you will have to write most of the things in each linear OP mode you create, which is quite counterproductive. Let's not mention the fact that as you keep adding more and more stuff in your code will become much more harder to read in the future. The solution to this mess is to break down the code into smaller and reusable chunks of code. In this way, we can reuse some of the components that are found on the robot whenever we want. For example, the chassis will be a module as well as other mechanisms you have mounted on your robot. Each module will have its own set of functions that will then be used in your OP mode. First of all, let's begin by making a basic module class. Because hardware map is only available inside the linear OP mode class, we will have to import it somehow. For this, we will create a constructor inside our class that will provide our hardware map for later use. Before we finish off, we want a way to initialize our module. The problem is that each module will have its own way of initializing things. For this problem, we will declare an abstract function called initModule, so we can implement it in each module we define. For now, the basic stuff has been done. Let's have a look at how this system works in practice. We will create a basic chassis class and then use it in our linear OP mode. First things first, we will define a basic chassis class that we will inherit all the features offered by the module class. Because in our module class we have one abstract function, we will need to define it inside our class. Let's say our chassis has 4 DC motors. We'll create them inside our chassis class, but don't forget to specify the type of data you will store in the variables, because we will leave them empty for a moment. Inside our initModule function, we will define our logic for getting the chassis motors. Now it's your turn to implement whatever you want to do with this module. In this case, we will implement a basic move method that will allow us to move the robot on the ground. And we are done with the chassis. Let's use it in our tele-OP mode. First of all, let's create our chassis by giving it our hardware map property and then initialize it. In my case, I will simply make it move forwards or backwards depending on the driver's vertical left stick position. This has been the FTC modular architecture in under 2 minutes, and see you next time.